Number 12 is testing if you understand definite integrals without using the calculator, because normally we would solve this in our calculator, but I'm actually showing you the work and seeing which one it's equal to. So let me just sort of work through how to do this by hand, and then I'll show you how you could have also solved this one using your calculator if you weren't sure. So basically here you have this, and what you need to do is you first, anytime you see this integral symbol, you need to find the antiderivative. So that's what we just did. You need to plus 1 divide by that number. So if I plus 1 here, I'm going to get 3 divide by 3. Okay? If I plus 1 here, I'm going to get 2 divide by 2. And you'll notice that these actually cancel. Now, this is asking you to go from 4 to 16. So you'll often see it written like this. Here's 16 and here's 4. What that means is take this function, plug in 16, and then minus this function with 4 plugged in. So what you would do is you would do 16 to the third over 3 minus 16 squared minus, now plug in 4. So 4 to the third over 3 minus 4 squared. Now you might notice that I've got brackets here because this minus is part of what this means. This means to do this one minus this one. So if you have a negative here, you'll then need to expand the negative, okay? So you'll end up with 16 to the third over 3 minus 16 squared minus 4 to the third over 3 plus 4 squared. So if you look at your answer choices, you'll see that it matches this one. The other thing you could have done is, for example, go ahead and solve it in your calculator. So in this case, I've got alpha x squared minus 2x, minus 2x. And then I'm going from 4 to 16, okay, and I've got 1004, I'm sorry, 1104 or 1104. And what you'll notice is, for example, if you think this is your answer, 16 cubed over 3 minus 4 cubed over 3, that doesn't equal 1104. So you know that one's not the same, okay? So then, for example, you could plug this one in, and again, you would get that it's not the same. You could plug this one in. So minus 16 squared, and then plus 4 squared, and sure enough you get the 1104. And you do need to be careful because I've been talking a lot about how you can sort of just plug two things in and see if they're equal. You do have to be careful because obviously if it's an original and a derivative, they won't actually be equal. But if all else fails and you have time left but you're just not sure how to do things, try things and see if something makes sense, okay? Don't just, if you can say, well, it's for sure not this one and it's for sure not that one. For example, this one was wrong because they have the formula twice and then the 16 and the 4, when really you should only have the antiderivative and then the 16 and 4. So if you can already say, oh, that's not the right one and this isn't the right one, at least now you have a 50% chance of getting it right. Okay?